So I have one more screencast to discuss that I'm going to use for this week's work. And one comment is this here, worksheet 3. I wanted to mention that there's a lot of quantitative qualitative questions, and I guess I was looking to use an equation here to describe how the electrical potential energy changed between the initial and final state. And I guess I thought it was kind of a jump that didn't have a lot of segue um, as far as getting the answers. So I didn't really have success in using equations to solve this problem um, because it seems that um, the potential difference would change as these charges separated, so it would be greater as the distance increased. And therefore, it seems that the electric energy would increase for number one. Okay, so I guess you could maybe put some scale on there as far as the distances. And then you could use, a math equation, or you could think about it qualitatively to get to the answer, which seems a more useful sort of approach for asking questions in the modeling scenario, since there's multiple ways to solve a lot of problems, but without um, values and specific measurements shown, then it kind of takes away some of the mathematical approaches to use to solve the problem. So I guess I would appreciate that. And then also, you can solve it from a work standpoint. So, for example, as you spread out the negative and positive charge from each other, it takes work. And so that's an input of energy. And so that's a pretty straightforward way to figure out, for example, number one, that the final state or situation has more electrical potential energy than the initial state, because it takes more work to separate two leg charges at a farther distance. And like for number two, for example, it would require negative work to separate two leg charges farther apart. Or you could say it would take positive work to bring them closer together. But anyway, just to comment on the nature of that. And then I also wanted to discuss the project that we're looking to do. So we need to read a paper and do a project on that, sort of a joint project. There are some ideas that I'm interested in, such as, for example, we've been doing an alternative energy project. It's basically a research project essay that students have to write on different alternative energy methods of production, such as OTEC, ocean thermal energy conversion, or fuel cells, or solar, or offshore wind or onshore wind turbines, or wave energy devices to harness energy for electricity. And so I was thinking of maybe relating some of this work here that we're doing to the application of electricity and electricity production in the real world in some of these newer alternative energy means. So I guess, I don't know that anyone else would be interested in that, but that seems like a really quite interesting sort of avenue to sort of apply some of this information. And it might give me some good ideas, to bring in some more examples with my students, as well as produce more curriculum with them. in terms of this kind of application of the work. I also thought it was interesting that I guess methods of storing charge is somewhat problematic because if electricity is generated, you have to kind of use that um, as it's being produced. Potentially, there's not a lot of ways to store that that electrical energy. As far as I know, I mean, it's I guess batteries. And so it'll be interesting to get into a little more how they work and also the variety of the different batteries that are out there. Um, and just the method of how, I guess they can store some of this electrical energy. And I'm not sure that that is even the case, but that's my kind of novice thinking about it. And then the capacitors, I understand, also can store charge. And then when you discharge a capacitor, I don't know that you can control necessarily the rate of discharge. I guess you could through a resistor, but some of that maybe I'm getting ahead of myself. And we will get to that when we start studying circuits and the flow of electricity, through wires.